There's something truly mesmerizing about watching raw metal transform under thousands of tons of force, and the Ruse Forging and Pressing Plant does it like few others in the world. Located in Ruse, Bulgaria, this facility has shaped heavy industrial components since the Soviet era, and today it's one of Eastern Europe's most respected names in hot forging. What you're watching is their roll shaft forging process, every step a small miracle of engineering. It starts with a steel billet heated to around 250 degrees Celsius, roughly 300 Fahrenheit. At that temperature, the steel glows orange and becomes workable. It then moves to a hydraulic forging press, where up to 3,000 tons of force compress and shape it. Each blow aligns the grain structure, making the final shaft far stronger than anything cut from solid stock. After rough forging, the shaft passes through multiple forming stages, then gets heat-treated to relieve internal stress and inspected with ultrasonic equipment to catch any hidden flaws. The finished roll shaft, smooth, balanced, and built for millions of cycles, heads to steel mills and rolling lines worldwide. That's the beauty of forging. It doesn't just shape the metal, it builds endurance right into the grain. Ever wonder what happens when one machine can mill, bore, and turn, all without ever moving the part? That's exactly what the NBH 630 MT from MAG does, and it's one of the most capable machining centers ever built. MAG, formerly Cincinnati Machine, has been building precision equipment for over a century, serving aerospace, energy, and heavy industry giants. When tolerances can't be compromised, this is the machine that gets the call. The 630 refers to the pallet size, 630 by 630 millimeters, about 25 inches square. That pallet locks the workpiece rigidly while the spindle attacks it from multiple angles. The MT designation stands for mill turn. This single machine both mills and turns a part without ever unclamping it. In traditional shops, you'd move the part from a milling machine to a lathe, and every refixture introduces alignment risk. The NBH 630 MT eliminates that entirely. One setup, one machine, near-perfect accuracy. The spindle itself is a precision-ground, high-torque unit capable of holding both rotating milling cutters and fixed turning tools. A built-in automatic pallet changer means a second workpiece can be loaded while the first is still being cut, dramatically reducing idle time. Watch that cutting head glide along the X, Y, and Z axes. A Siemens or Fanuc CNC controller manages everything simultaneously: spindle speed, feed rate, coolant flow, tool compensation. Every pass calculated to the micron. The plate being milled here is likely a high-tensile steel or cast iron alloy. Face milling removes material fast, while final finishing passes use smaller end mills or boring heads to hold tolerances as tight as 5 microns. Roughly 1/10 the width of a human hair. On a horizontal machine, chips fall away by gravity rather than piling up on the part. Cleaner cuts, longer tool life, better finishes. For gearbox housings, engine blocks, and structural components, horizontal machining is the gold standard. The NBH 630 MT doesn't just machine parts, it redefines what one machine can do. Steel pipe. You probably don't think about it much, but it's everywhere. It carries the oil that heats your home, the water from your tap, and the gas that runs your stove. And most of it comes from places like Tenaris Bay City. Located in Bay City, Texas, Tenaris Bay City is one of North America's most advanced seamless steel tube facilities, specializing in oil country tubular goods, the heavy-duty pipe used in oil and gas drilling. Their manufacturing process is equal parts brute force and surgical precision. It begins with a solid steel billet, a thick cylindrical rod of high-grade carbon or alloy steel, cut to length and loaded into a rotary hearth furnace. It heats uniformly to around 250 degrees Celsius. Even heat is critical. Uneven temperatures produce varying wall thickness, and uneven pipe walls can fail catastrophically thousands of feet underground. From the furnace, the glowing billet enters the piercing mill. Two barrel-shaped rolls grip it and spin it at high speed, while a hardened steel mandrel is driven straight through the center. The metal doesn't cut, it flows. This rotary piercing action hollows the billet without a weld seam. That's the defining feature: seamless. The resulting hollow shell is then elongated through a series of rolling mills, stretching and thinning the walls to precise target dimensions. Wall thickness can range from a quarter inch to well over an inch depending on application. After rolling, a straightener removes the curves introduced by heat and pressure. The pipe is cut to length, inspected with electromagnetic and ultrasonic tools, heat treated for required mechanical properties, and finally threaded on a CNC machine, because every connection on a drilling rig has to hold under thousands of pounds of pressure per square inch. From solid billet to finished threaded pipe in just a few hours, built to work silently and reliably a mile underground. Now here's a machine that commands respect the moment you lay eyes on it. This is the Roundo R13S, a heavy-duty section bending machine built to tackle one of the most challenging tasks in structural steel fabrication: bending a massive HEA 650 beam the hard way. That means bending it along its stiff axis, where the resistance is greatest. Roundo machines are legendary in the fabrication world, and for good reason. The advanced hydraulics system ensures smooth, controlled movement throughout the entire bending cycle, with continuously variable speed adjustment, so operators can dial in exactly the right feed rate for each job. But here's what really sets the R13S apart. It's equipped with interpolating axes. That means the machine can produce multi-radius shapes along a single profile in one continuous pass, something that used to require multiple setups and a lot of manual guesswork. The Roundo WCNC4 software package takes this even further, bringing a full profile library, automatic bending cycle calculation, unlimited program storage, automatic axis interpolation, and self-calibrating routines directly to the operator's fingertips. There's a certain satisfaction in watching a massive machine come together, piece by piece, bolt by bolt. And if you want to see that at the highest level, look no further than the Komatsu plant in Birtley, County Durham in northeast England. Komatsu. If you've spent any time around construction sites in the last 40 years, you know the name. Founded in 1921 in Japan, Komatsu is the world's second largest construction and mining equipment manufacturer, right behind Caterpillar. Their Birtley facility has been producing hydraulic excavators since 1987, one of the oldest Komatsu plants outside Japan, and a point of real pride in British manufacturing. The line here produces crawler excavators in the 20 to 50 metric ton class. These are serious machines, built to dig foundations, lay pipelines, and move the kind of earth that reshapes a landscape. It starts in the fabrication hall, where structural components, the undercarriage frame, upper house, and the long boom and arm assemblies are welded from thick steel plate. Robotic cells handle repetitive welds for consistency. Certified human welders tackle the complex joints. Every weld gets inspected because these structures will face enormous dynamic loads in the field. The undercarriage comes together next. Track frame, rollers, idlers, and drive sprockets, all precisely aligned. Track alignment directly affects wear life. A few millimeters off-spec and components that should last years wear out in months. Then the upper house is built up around the hydraulic system, and it is extraordinarily complex. Hundreds of feet of hydraulic hose, multiple control valves, and a main pump driven off the engine. On a 50-ton machine, that pump flows 200 liters per minute at pressures exceeding 350 bars, more than 5,000 psi. Every fitting has to be right. The engine, a Komatsu SAA 6D140 Tier 4 final diesel, is installed as a complete power pack with its cooling, air filtration, and emissions after-treatment system. Meeting modern emission standards while maintaining full power output is a genuine engineering balancing act. The upper house is then lowered onto the undercarriage and bolted to the slew ring, the massive bearing that allows 360-degree rotation. Boom, arm, and hydraulic cylinders are pinned in, the system is filled and pressure tested, and every function is cycled under load before the machine receives its paint and decals. What started as flat steel plate just days earlier rolls off the line as a 40-ton precision machine. That's Komatsu Berkeley, British craftsmanship, Japanese engineering built to last.